So, in this video, we're going to look at question 10, page 172. We're just going to deal with parts 1 and part 2 of the question because we don't have part 3 covered yet in class. So, we forget about that for a while and we can come back and finish that later. So, given the coordinates for two planes A, B, C, and D, E, F, determine the line of intersection between the planes and determine the dihedral angle between the planes. So, we start with the very first line, determine the line of intersection between the planes. So just to speed up the video a small bit, I have the points plotted out here in plan and elevation, and I'm just going to work on now finding that line of intersection. So there is no common point in these two laminas, right? There's no common point. So I'm going to have to draw two level lines in my elevation, find them down in plan, and that's going to give me that line of intersection then. So, if we remember from class, we try to go from corners in our laminas just because it's going to make the whole thing easier to find it down in the plan. So I'm going to go right across here with my pink one. I'm going to label these. So F, the triangle EFD, it cuts it there in F and it cuts it over here in E. I'm going to call that 1. I'm going to call where it cuts CB 2 and 3. So we know where point F is. Now I'm going to bring down ED, point 1, till it hits ED down on my plan. That now is point 1. I'm going to bring point 2 down until it cuts CB. That's point 2. I'm going to do the same with 3. Cuts AB. Point 3. So we can join up our corresponding points now. So it goes 1 to F, and it goes 2 to 3. I'm just getting that from up here. So triangle ACB has points 3 and 2, and then the other triangle has points 1 and F. So that's my first one, and it gives me a little X right there in the middle. I must do the exact same in elevation, and this time I'm going to go from corner A. I need to draw a level line. I'm going to call this, I'm going to use the same numbers, but it's in blue this time. So triangle A, 1, 2, 3. So A and CB 1 there, bring it down. Bring down point 1 in blue till I hit CB. That's 1 in blue. Bring down 2 till it hits AD. That's point 2. And point 3 cuts EF. That's 3. So it's A to 1. So point 1 gets joined up to A. It's 2 to 3. And that gives me another little X. Our line of intersection now goes through those two X's, and it's in between the shortest distances in the lamina. So basically until you hit a line of one of the laminas, that's where we stop it. So that red line is my line of intersection of my lamina in plan. To find that elevation, we just bring it straight up. So it cuts AC at this point. So AC, it cuts it right there. And it cuts FD. Cuts FD there. So that's my line of intersection in elevation and my line of intersection in plan. So that's the first part of the question found. Second part of the question asks us to find that dihedral angle. So, to find the dihedral angle, first of all we're going to have to see that line of intersection as a true length, and then we're going to have to see it as a point of view. Okay? So the very first thing, to get anything as a true length, we're going to have to set up an x1, y1 perpendicular to that true length line. So parallel. So we're going to set our x1, y1 parallel with the true length line. Now we can bring up all our points of our laminas. I'll bring the triangle ABC first up. So ABC. And we go back to 1 view, 2 view, so we're going back to our elevation for our heights. I'm going to set up a little datum line there in my elevation, just so I'm getting rid of all that empty space between the XY line and the shape. So B is on the ground, so that means it's going to be on the XY line. So is this distance away? So C is here. That's A. C. A. Now I'm going to bring the rest of my points. E. D. I'm going to draw in my two laminas here now again in this view. So I'll pause A, B, C. Back up to A, and it goes D, E, F. Okay, so I'm going to need to find the line of intersection now in this view again. So what I can do is bring it across from my plan where it hits the corresponding line. So it's F and D, this point here. So I'm going to bring it across my F and D. So it's that there. It hits A and C. This point up here, so A, C. So join my two dots. So that's the true length of line of intersection. Why is that the true length, or how do we know that's the true length? Because our x1, y1 is parallel with the line of intersection in plan, meaning its next view is a true length. Okay. Now I need to get a point view of that, so I'm going to set up an x2, y2 perpendicular to that line of intersection, and I'm going to get my dihedral angle from that then. So that's my x2, y2. I'm going to bring down my points from my auxiliary elevation. So I'll do A, B, C first. A, B, C. Once again, I'm going to set up a data line. So I'm going 1 view, 2 view back. So it's going to be from my plan to my x1, y1. But I'm going to set up a datum line here again, down through A. And that's where I get my heights. So A is on the ground. I'm just touching that datum line. That's A. B is from the datum line back, so B is a nice distance. That's B there, right at the bottom. And C is this distance back. Now I can bring my other points. D, E, and F. E, F, and D, which might struggle to be on the page. That's point D. Just gonna run back and check my ABC one. So A is on the datum, so that's that. C is this far away. And I bring down point C. And B then. Yep. So we can just join in our points then. So if we're accurate enough, it should make up straight lines. Mob it out there. Runs off up out the page there where B is slightly off the page there. And any one of them then, we can say is our dihedral angle. So any one of them four. So it's DI. So that's the question there complete. When there's two laminas and they don't share any common point.